Now finally we're going to look at a particular random number generator. This random number generator is RC4, where RC stands for Ron's code. It's not considered a cryptographically secure random number generator anymore because weaknesses have been found since the 1990s when it was widely used. So you shouldn't use it, although you may see it used still in some places. RC4 has an internal state of 258 bytes. 256 of them are initialized with indices 0 through 255, and then we also have a number I and a number j on top of those. So in pseudocode, we might define the state like this, an array S with an I and a j also. The array starts out with 0 through 255, but if we just started generating random numbers from that state, then everyone would always get the same numbers. So we need a way to seed this generator to change its internal state to a unique starting position. Here's some pseudocode for how the state of RC4 is initialized from a seed. We'll call the seed the key. We'll supply it as a string, and we're going to use the individual characters of the string, looking at them as parts of the key. And the key can be any length, but typical values are between 5 and 16. More than 256 will not be useful because of the way that we're going to use it, and less than 5 is just too few. We use this key by starting with j equals 0 and then letting I range from 0 to 255. So I is going to walk across all the positions. It's going to use the ith element of the key, where I will wrap around when we get beyond the key's length. It's going to take that and add it to the current value in our internal array at position I, and it's going to add that to j, and then it's going to move j as a result, modulo 256, so that j stays in bound. So now we've got I and j at different positions, and we're going to swap the values at I and j. So I is going to walk across, and j is going to jump around, and we're going to keep swapping these numbers, and this performs a kind of shuffle. At the end, we set I equals 0 and j equals 0 back, so we are ready to go now generating random numbers. We have shuffled all the numbers in the array. And here I'm showing the actual array that you would get if you shuffle using the key secret. After we've used the key or seed to initialize the state, now we can start asking for numbers. So next byte here corresponds to a call to random. It's always going to give a random number between 0 and 255. And the way next byte works is we're just going to move I forward, but we're going to move j around by taking the value at the index of I, adding that to the current j, and then wrapping around as needed by mod 256. Then, just like we did when we were initializing the array, we will swap the values at I and j, and then finally we're going to take those two values, the ones we just swapped, add them up, again wrap around at 256, and use that as an index into S one more time and return that number. So we're always finding some number in this array while we're swapping things around and moving j around. So if we start in this state, we're going to take I plus 1, which is 51. We're going to look at the 51st element here. We're going to add it to j0 and do some swaps and returns, and it turns out we will return the number 235. And you see that j index now has a 51, which used to be up here at our incremented I index. And if we ask again, we'll get a 159. And if we ask again, we'll get a 119 and then 129. If you implement RC4 yourself, you can check your implementation against those first 4 bytes at least, and the Wikipedia page will give you some more starting seeds and the numbers you should expect from those. Of course, when RC4 was used for cryptography, the secret keys would be kept secret, not published in Wikipedia. But it's not used that way anymore because it turns out that the first few bytes that you get from the random number generator expose information about the key that you used to set it up. You can address that by throwing away the first few random numbers, but that's not the only problem. There are also some biases in the generated numbers, like certain pairs showing up more than they should, more than they would in a purely random sequence, or some pairs that have been generated showing up again in the output stream more often than they statistically should show up. So for these reasons, RC4 is not used for cryptographic purposes anymore. But it does give you a sense of the kinds of things that a random number generator does on the inside with its state.